I'm Anil Kumar. Welcome to my series on lines. We're talking about gradients and relating the slope with the tangent of an angle. In this video, we are going to discuss three important aspects. One of them is angle between lines. Now from here, we'll derive an expression for parallel and perpendicular lines. We'll also look into reflected rays. And then we'll take some examples which are very critical from test point of view. So in this video, I'm also going to take a short break after discussing parallel and perpendicular lines examples. And then we'll continue with our test related questions. So basic things which we will be looking into is first, angle between lines. What do we really mean here is, let's say we have a line in this fashion, another line we have something like this. Now what you can see here very clearly is that if one line makes an angle of theta 1, the other line makes an angle of theta 2, then we are interested in this angle theta. But in lines, you will always notice that there are two angles between them. We could be talking about the acute angle theta or the other angle, which could be as written as 180 degrees minus theta, right? So both these angles are angles between lines. Perfect. Now when we say parallel and perpendicular lines, it really means these are the parallel lines, correct? So they will never intersect. The angles between them, well, when we try to figure it out, since they are same, let's say this is theta 1, this is theta 2, we'll say theta 1 equals to theta 2. However, if we have a perpendicular line, then if this is perpendicular, in that case, the angle will be what? Look into this, right? So this angle here is sum of these two angles, interior angles. So if they are perpendicular lines, then theta 2 will basically be equal to 90 plus theta 1, right? For perpendicular lines, right? So we'll derive that relation which relates to parallel and perpendicular lines. Now, reflected rays basically means that if I have a line like this, then it is going to get reflected. We'll say reflection is from the x-axis. And whenever it gets reflected, in that case, the angle which is formed here, let's say this is theta, is also same as the angle of the reflected ray from the normal, right? So let's say this is the point of reflection, then these two angles are equal. So that should help us to find relation between the lines and the angles. Now let's look into details how to mathematically calculate these values and relate them. So let's first talk about the angle between the lines. So let me again sketch the diagram which we'll refer to. So let us say that we have a line which is increasing. Let's say this is the line which is increasing. Okay. I should have drawn the axis kind of like this. Okay. And let's make the other line which is decreasing. So these are two lines. Let's say the points are A, B, and let's say this point here is C. The angle which first line makes is theta 1, the angle which the other line makes is theta 2. Always the angles are anti-clockwise from positive x-axis. Perfect. So therefore we always take these as theta 1 and theta 2. Now when we say angle between lines, we're talking about this angle theta, which is between lines, right? So that is the angle theta which we're talking about. Is that clear to you? Okay. Now to get this relation, we know that theta 2 is exterior angle. So angle theta 2 should be equal to angle theta plus angle theta 1, right? Since it is exterior angle. is sum of, that's the theorem, right? Sum of remote interior. Correct? Even otherwise, you can figure this out. This angle will be 180 minus sum of these two, and that is 180 minus that angle. Correct? So you get it either way. So we are interested in angle theta. So let me isolate theta. Theta gives you theta 2 minus theta 1. Now taking tan on both sides, we get tan of theta equals to tan of theta 2 minus theta 1. Now we can expand this tan theta 2 using the trigonometric formula, which will be tan theta 2 minus tan theta 1 over 1 plus tan theta 1 times tan theta 2. Correct? So this is trigonometric formula, which you know what is tan A plus B equals to. So you know tan A plus B could be written as tan A plus tan B divided by 1 minus tan A tan B. However, if you have negative here, then the signs are like this. Is that clear? The ones which we have used here, since we have negative, correct? So that is how you could write. And now in gradients, what did you learn? Lines and gradient. We know slope m is basically equal to tan theta, right? So that clearly means that the angle is basically tan theta 2 means slope of line 2 minus slope of line 1 divided by 1 plus product of these two slopes. Correct? Since tan theta represents the slope of the line. So that becomes a relation for the angle. Now you can always calculate what theta is. So from here you can always write theta is tan inverse of this angle, which is m2 minus m1, this value that is, right? m1, m2. Perfect. So that is how you could actually find the angle theta. Now one thing is very important, and that is to say that this angle is also angle between the lines, right? So this is how much? This is 180 degrees minus theta, right? Now, if you look into it, what is tan of 180 degrees minus theta equals to? Well, that is equals to minus tan theta, correct? So tan of 180 degrees minus tan theta is minus tan theta. So then, what is this? This tan theta is that angle. So minus tan theta can be written as negative of m2 minus m1 over 1 plus m1 m2, correct? Now combining these two, since we know the angle could be obtuse angle or this acute angle, the general expression could be written as tan theta equals to plus minus, right? It could be negative or positive, m2 minus m1 over 1 plus m1 m2. Is that clear? So that becomes a very important relation for us to find the angle between the two lines. Is that clear, right? So now we understand how to find the angle between the lines. And in the next page, let's consider parallel and perpendicular lines, right? So we'll begin with the given formula here, which is tangent theta equals to plus minus difference of their slope divided by 1 plus product of their slopes, correct? So let me write down the formula here once again. So basically we have tan theta equals to m2 minus m1 over 1 plus m1 m2, right? We have seen that angle could be plus or minus since we are considering the acute angle or the obtuse angle. Both are the right angles, correct? Okay. Now let us consider the cases. When are they parallel and when are they perpendicular, right? So case 1, let's talk about parallel lines. So parallel lines means that the angle between them should be 0, right? So that means theta should be equal to 0 degrees, correct? Now if theta is 0 degrees, then what do we get? So in that case, tan of 0 degrees is basically 0. So that means that m2 minus m1 over 1 plus m1 m2 equals to 0. Now this is 0 only when m1 is equal to m2, correct? So we conclude that lines are parallel if they have same slope. Now of course there could be two conditions. They could be collinear also, right? Perfect. Now that is our first case, parallel lines. In the second case, let's consider the perpendicular lines. Now when are they perpendicular? Perpendicular means theta equals to 90 degrees, right? So the angle between them is 90 degrees. So in that case, what is tan of 90 degrees equals to? Well, that is undefined, right? So undefined means what? Well, we know that tan theta is basically equal to plus or minus m2 minus m1 over 1 plus m1 m2. So undefined means what? This implies that the denominator here, which is this portion, should be 0. That means 1 plus m1 m2 should be equal to 0. Or this implies that the product m1 times m2 is minus 1. So that is the condition, correct? So the condition here is that the product of the slopes of the two lines should be minus 1, correct? Or you could write m1 equals to negative 1 over m2, or they are negative reciprocal. Is that clear? So from here we could actually find the condition for the lines being parallel or perpendicular. So I hope you find it interesting. Now let's move on and take some examples based on the concepts we have just learned. Question number 1 here is find the angle between the lines x plus y equals to 0 and x minus 2y equals to 3. So we are given two lines. One is x plus y equals to 0. Let me write this as y equals to minus x. That means slope of this line is minus 1, correct? We are comparing it with the form y equals to mx plus b, where m is slope. Perfect. Now for the second line, we have x minus 2y equals to 3. We could write this as 2y equals to x minus 3, or y equals to half of x minus 3 by 2. So the slope of this line is half. So once we know the slope, we can find the angle between the two lines, correct? Now angle between the two lines, we have the formula tan theta equals to m2 minus m1 divided by 1 plus m1 m2, correct? So we can write from here m2 is half minus 1 over 1 plus, we have half times minus 1, correct? So that gives you what? That gives you 1 plus 2, taking 2 common denominator right here. And in the denominator, we have 1 minus half. Correct? So we could simplify this and write this as 3 over 2. So that is the numerator. And here 2 minus 1, right? 2 minus 1 is 1. That is 1 minus half is half. So times 2 over 1, correct? So that gives you the value as 2 and 2 cancel, 3. Is that clear, right? So 1 minus half is half, which I could write as 2 over 1, right? So we get tan theta equals to 3. So we have tan theta equals to 3. So theta equals to arctan or tan inverse 3. So let's use the calculator to find the angle, right? You could write tan inverse 3 also. So shift tan inverse 3 equals to 71.56. So theta equals to 71.6 degrees. Do you see that? So that is how we can find the angle between the two lines, right? Question number 1a, find the angle between the lines x plus 2y equals to 0 and y equals to 2x minus 3 is for you to practice. Clear? Okay. So let's see the next example. Now the question number 2 here is, a ray of light passing through the point 02 reflects on the x-axis at a point R, and the reflected ray passes through the point 46. Find the coordinates of point R. Now I'll take up this question after the break. Okay? You can try it meanwhile. I hope you enjoyed the break. The birds here are really beautiful and they normally fly in a straight line. Now let us see how to answer question number 2. A ray of light passing through point 02 reflects on the x-axis at point R, and the reflected ray passes through the point 46. Find the coordinates of point R. Now this is a very interesting question. Let us see how to solve this question and also understand the strategy of solving similar questions, right? So point 02, let's say this is our point 02, is reflected on the x-axis and is passing through, let's say it goes like this and then it gets reflected. Okay, so that is how it is turning out to be. The point here 02, let's say this is 2. We don't know the coordinates of this point. We are calling this point as R. However, it is on the x-axis, so we can always write this y value as 0. So let's say we write this value as lowercase r and 0. Okay. We are given a point on this line, on the reflected line, as 4, 6. Correct? So that is the scenario. Let's call this point as A here and B there. Now, what is the slope, or what is this angle here equal to? What should be this angle? Let's call this angle as phi, right? So we know tan of phi should be equal to slope of this line, right? A slope of the line BR. Now slope of the line you can find using y2 minus y1 over x2 minus x1, correct? So in this case it is 6 minus 0 over 4 minus r. Okay. Now when we're talking about reflected lines, let's consider this to be the normal. Let's call this some point here as n. In that case, what we really know is that these two angles are equal. Correct? So let's say this angle is theta. In that case, this is also theta. Well, we also know that this total angle is 90. That means phi is equal to what? Phi is equal to 90 minus theta. Is that correct? So the angle phi is 90 minus theta. So I could write on the left side, tan of 90 minus theta is basically equal to 6 over 4 minus r. Now from cofunction identities, we know tan of 90 minus theta is basically cotangent, right? Is equal to cot of theta, right? So tan of 90 minus theta is, so when we say let's look into any particular triangle, let's try to understand this concept also. Let's say we have a triangle here, right? If I'm saying this angle here, let's say this angle is theta, right? And this angle will be 90 minus theta. Is it okay? When that is 90. Now, you can clearly see that tan of theta is this ratio, right? That over this, and cot of theta will be 90 minus theta will be the same ratio. So tan of 90 minus theta is cot theta. We call this as a cofunction identity. This is called cofunction identity. Is that clear to you, right? So this is called cofunction identity, right? So we get cot of theta is basically equal to 6 over 4 minus r. So let's call this as our equation number 1. Okay. Now let us consider the line A to R, right? So what is the slope of this line? So slope of M of AR is equal to what? Is equal to, again we'll use the same formula, right? So we get 0, 2 here, the coordinates r and 0. So using y2 minus y1 divided by x2 minus x1, we get 0 minus 2 divided by r minus 0, which is minus 2 over r. Now, the angle here is 90 plus theta. This side makes 90 plus theta angle, correct? So this is basically equals to tan of 90 degrees plus theta. And that is equal to minus 2 over r. Correct? Now tan of 90 plus theta is minus cotangent theta. So this could be written as equal to minus cot theta. So that is again a function identity. If you look into these triangles, let's get back to this also, try to understand the trigonometry behind, right? When we consider the angle theta, so if we have this angle theta, correct? In that case, let us say this is 90 minus theta, right? So here tan is negative, correct? Here tan, all are positive, right? All are positive. Here sine is positive, tan is positive in quadrant 3. Since tan is negative, we have minus cot theta. Do you get the idea, right? So minus 2 over 3 is minus cot theta. We'll call this as our equation number 2. So we have an expression for cot theta as 6 over 4 over r and minus cot theta as minus 2 over r. So from here, I could also write this as cotangent cot theta as 2 over r. Correct? And now we can equate these two equations. Both are cotangent thetas, right? Equating that will solve in this space. What do we get? So here we get 6 over 4 minus r is equals to 2 over r. Now we cross multiply. We can simplify also. So we get 6r equals to 2 times 4 minus r. Now dividing by 2, it becomes 3. So we get 3r equals to 4 minus r. Bringing this on the left side, 3r plus r equals to 4. And that gives you the value of r equals to This is also 4r, right? So r equals to 1, correct? So we find that the value of r is 1. Perfect. Therefore, the point under consideration, capital R, is basically 1, 0. You understand how we got, right? This is 4r equals to 4. That means r is equal to 1. Now I'd like you to pause the video, go through this solution once again. Here is our line AR, which is being reflected, goes through point B, which is 4, 6. Let the angle with the normal be theta. For the line which is incident on this reflected line will also make the same angle. Let phi be the angle with the positive x-axis. Then the slope of line RB is tan phi. Slope of line AR is 90 plus theta. So that gives you the value of 2 in cotangent theta, which can be equated, and we could find the answer. So I hope you understand this critical step. So that's a test question for you. Perfect. So with this, we kind of complete our video on understanding how to relate lines with gradients, angle relationships, when we are talking about parallel perpendicular lines, and also considering reflected lines. Now, here are a few practice questions for you. I would like you to pause the video, copy the question, solve it. So question number 3a is, given the point A, which is 4, 3, and B, 6, 4, and C, 5, 6, find the angle between BA and BC. Okay, so that's one question. Let's do this question. So the angle between BA and BC we have to find. So we are given point A, which is 4, 3, and we are given point B, which is 6, 4. Let us find the slope between points A and B, right? So which is equals to y2 minus y1 over x2 minus x1. This slope is basically 4 minus 3 divided by 6 minus 4, or is equal to 1 over 2. Now let us also find the slope between the BC is the other one, right? So now we know that point B is 6, 4 and point C is 5, 6. So the slope between B and C is basically equal to 6 minus 4 divided by 5 minus 6. That gives you 2 over minus 1, right? So minus 2 is the slope of this particular line. So MBC is equals to minus 2. Now we need to find the angle between the two lines, right? So the angle between the two lines will be tan theta, which is M2 minus M1 over 1 plus M1 M2. So we can find using these values. So this is M2 for us, minus 2 minus half over 1 plus this is minus, so I'll write minus 2 times half, right? So that gives you minus 3 over 2, right? This, when you add this up, 2 times 2 is 4, and 4 and 1 becomes 5. So minus 5 over 2 in the numerator. This is 1 minus 1, which is 1 minus 1. 1 minus 1 is 0, right? So it is undefined. Correct? So what we get here is we get 0 in the denominator. So tan theta is undefined. That implies what? That means theta is 90 degrees. Correct? So that shows that these two lines are perpendicular, right? So since the angle is 90 degrees between them, we can say that BA is perpendicular to line BC. Is that correct? So if you get slope which is 90 degrees, slope which is undefined, that means the angle between the two lines is 90 degrees. They are perpendicular. Is it okay? Now, follow the same strategy and try to do 3b. Given the points A, B, and C, which are 1, 2, 3, 4, 5, 6, find the angle between BA and BC. Okay? So I hope with these set of examples, you understand how to work with lines, figure out the angles between them, and also find whether the lines are parallel or perpendicular, right? So we have understood all these cases. We have also understood how to work with reflected rays. So with this concept in mind, I'd like you to try the questions in the next video where we will have some challenging questions. Also, a situation where if you find the slope as undefined for a particular line, then how do we treat that example in a very special way? So with that, we'll end this video. I hope you understand and appreciate the concepts learned. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.